Welcome back to lesson 4, vectors in 3 space. So we're going to finish off with example 6 and example 7. So given vectors u, v, and w, simplify each vector expression. So the first one looks like this. I have negative 3u, so that's my scalar times my vector u. So this is really equal to negative 3 times the vector u, so 2, 3, negative 5. And so what I'm doing here is I'm simply just multiplying in this into each coordinate. So this is really going to be equal to the vector negative 6, negative 9, and 15. If I want to do u plus v plus w, what I'm going to do here is just add up all the first coordinates. So 2 plus 8 plus negative 6 is my first coordinate of u plus v plus w. Then it would be 3 plus negative 4 plus negative 2. And then the last one will be the last coordinate, so it's going to be negative 5 plus 3 plus 0. And so u plus v plus w is really equal to 4, negative 3, and negative 2. So again, given the same vectors here, I want the magnitude of u minus v. So what I'm going to do is find that vector u minus v first. So this is really equal to the magnitude of, I'm going to do u minus v. So the first one will be 2 minus 8, comma. The middle coordinates are going to be 3 minus negative 4, comma. And then here the last one's going to be minus 5 minus 3. So I'm just subtracting u minus v. So this is going to give me magnitude of negative 6, 7, and negative 8. So I can square and add now, square and sum. So I'm going to have negative 6 squared plus 7 squared plus negative 8 squared. And this will give me 36 plus 49 plus 64, which will give me a total of, I need to find my calculator. Here it is, 149, the square root of 149. All right, b is u dot v, so this is simply just multiplying each coordinate together, so 2 times 8, and then adding them, so plus 3 times negative 4, plus negative 5 times 3, so I multiply these together, and then add them, and here I'm going to get negative 11. What does that mean? That means that the angle between u and v is between 90 and 180. So given vectors a and b are collinear in 2 different ways. So show that vectors u and b are collinear in 2 different ways. So the first one I could just show that one's a scalar of each other. So I can use that going back to example 5. I believe I'm going to show that each ratio is equal. So the first one I'm going to put up 6. I'm going to put up the first coordinates. Whoops. So here I'm going to have 6 over 9. So the first coordinate of A over the first coordinate of B is equal to. Now the middle coordinate's 2 over 3, and that's equal to 4 over 6. I can see that I can simplify this fraction down to 2 over 3. This is also 2 over 3. And this simplify that fraction down to 2 over 3. Since all the ratios are equal, then the two vectors are collinear. All right, example 2, show that the angle between the two vectors is 0 degrees. So this is going to take a little bit more work. So here I need to find the angle. So I'm going to do cos of theta is equal to A dot B over magnitude of A, magnitude of B. So here we go, A dot B. So multiply them together. So I'm going to here have 6 times 9 plus 2 times 3 plus 4 times 6 all over square root of 6 squared plus 2 squared plus 4 squared. And this is times square root of 9 squared plus 3 squared plus 6 squared. And so this is going to give me 84 over square root of 56 times the, square root of 56 times the square root of 126. And if I do this in my calculator, if I cos inverse this, so cos inverse both sides, I will get theta is actually equal to 0 degrees. So since the angle between the two vectors, tail to tail, is 0, that means that the two vectors must be collinear. This method, method 1, is much easier, but method 2 also shows that it works. All right, find an orthogonal vector. So find a vector that is orthogonal to 3, 4, and 5. If two vectors are orthogonal, then the dot product between the two vectors is 0. Also, there are infinite possibilities. Why? Because there are infinite possible vectors that is orthogonal to 3, 4, 5. So we're going to find one. So what do? Well, I'm going to find another vector here that I can dot with 3, 4, 5 to give me 0. So I'm going to randomly choose the first and second coordinates, and then I'm going to solve for the third. So I'm going to go to the easiest one I know. So I'm going to call this, let's call this vector u. And so I'm going to have a vector v. So vector v, I'm going to choose my coordinates. The first two I'm going to choose is 1, 0. And then the last one I'm going to do an unknown, so I'm going to call it z. Now, you can choose anything you want here. The only one you cannot choose, and this is really important, is 0, 0. Why not, Mr. Wills? Because if you did 0, 0, guess what your third coordinate will be? It will be 0 as well. And now you've got the 0 vector. So you don't want to do that. So again, choose two. Any two you want. You could choose 1, 1, or 0, 1, or 1, 0. As long as they're both not 0, you're good to go. And now I know, because they're orthogonal, I'm going to dot them together. So I know u dot v is equal to 0. So I'm going to dot them. Here we go. So I'm going to have 1 times 3. Let's be consistent here, sorry. So I'm going to do u first. So it's going to be 3 times 1 plus 4 times 0 plus 5 times z, and this is equal to or 0 because they're orthogonal. So here I'm going to get 3 plus 5z is equal to 0. Bring the 3 over, divide by so here I'm going to have 5z is equal to 3. So that means z is equal to, that should be negative 3, my apologies. So z is equal to negative 3 over 5. So what does that mean? Therefore, 1, 0, negative 3 over 5 is orthogonal to the vector 3, 4, 5. And again, you can choose anything you want for these first two coordinates, then you just solve for the third. The only thing you cannot choose is, of course, is 0, 0.